Hello and welcome to my GUI Framework Fundamental series. Today I'll be telling you about containers and container layouts. So what is a container? A container is exactly what it says on the tin. It is a container. It contains things. It contains gadgets. And gadgets can be other containers. And that's it, basically. We have a root container, which is the window. So this is the window provided by GLFW or SDL or your own code. And this grey box in the centre contains an invisible gadget or container. And this container always scales to the size of the operating system window. So GLFW, every frame, will tell you if you've resized, and we will tell the container to resize to that dimension. So that is our single point of truth. That's our entry point. We know exactly what our root container size is. And we start at this root container and say, okay, do you contain any children? If so, let's sort out your layout and draw them. So we basically use two types of container. The first one is a vertical container, and this means we draw its child gadgets, like these labels, actually child gadgets, top to bottom. So we start at the top and just draw them and increase the Y value every time, and we add some space in between each gadget so they're nicely padded. We can also have a horizontal container, which is a mirror image of the vertical one. So instead of drawing the gadgets top to bottom, we draw them left to right, and we add spacing in between each gadget as we go along. And as we rescale the window, the height and width of its container may change depending on its parameters. This horizontal container has been told to stick or scale to the width of its parent container, which is the root window, but remain at a fixed height of 200 at all times. So no matter how big we make the window, the height never changes, but the width does change. And if we go back to the vertical layout, this one has been told to again adhere to the height of its parent container at all times, but scale horizontally by a ratio, a fixed ratio, depending on the size of the parent container. So we can make it bigger by dragging it across and down, and we can make it smaller down to a fixed minimum width, which is 300 in this case. So we can't go below 300 for that panel size. Well, we can go as high or as small as we want. Okay, so that's a container. It's basically a box that is housed inside another box, and that goes all the way up to when you get to the end, which is the root window. So boxes within boxes within boxes. So these are gadgets. These labels are gadgets within this container, but let's add one that we can actually see a bit better. Okay, this is just a box, a button. So we can click on it and it works like a button. Okay, it's labelled fixed width and height. So what does that mean? So when we've set up this button, we've said, I want this rectangle to be, I think it's 200 width and 20 high at all times. So no matter how you scale the container, it will remain at 200 by 20, which is great. And then let's add some more. So what we've done here, we've added two more buttons, but these are slightly different. We've said we want a fill width and a fixed height. So fill width basically says we want these gadgets to fill the horizontal space or the width of its parent container at all times, and a fixed height, we want this one to be 20 and this one to be 50 at all times. So if we scale the window, you can see their width changes, but their height remains constant. So for a vertical layout container, the only thing we're really interested in is the height of its child gadgets, because if you think about it, the width of each gadget can either be fixed or fill. It can't be anything different really. It can either be a fixed number that we assign, or it can be the entire size of the container. So we can kind of forget about width when we're doing a vertical layout container. And conversely, for a horizontal layout container, we can forget about gadget height, because that can either be the height of the container or a fixed height. We were interested in width in that context. Okay, so those are pretty easy. So how do we do the layout? Because as you can see, these are just automatically populated and positioned with no input from ourselves. We do not do gadget button 1 is X whatever, Y whatever, button 2 is X something else, Y something. We don't do that, it's all automatic. So whenever we force a layout change, or we rescale the window, or we do it manually, we basically enter the layout operation, which is split into 2 steps. So this is quite important. The first step is the measurement step, and the second step is the position step. So for the measurement step, we get the container and we go through every one of its children, and we say, first off, we want to know how much space the fixed height in this context gadgets take up inside this container. So we go through all the gadgets to say, right, are you a fixed height gadget? Yes, we are. How big are you? How big do you want to be? Well, these labels want to be 18, I believe. And this one wants to be 20, this one wants to be 20, this one wants to be 50. And then we say, okay, I know the height of all my fixed height gadgets in total. That leaves me with all this remaining space at the bottom to use. But I've got no more gadgets, so okay, I'm happy. Then we go to the position step, and that's very simple. We just start at the top with y equals 0 and draw the first gadget, and then say, okay, during your measurement phase, you set your height, add your height to the current y value, add a bit of padding, and draw the next gadget. And again, add a bit of padding, add the height value, and draw the next gadget. Add a bit of padding, add the y value, a height value, and draw the next one, and then draw the next one. So that's all the fixed height ones drawn, and that's it. So if all your gadgets are fixed height, it's a simple measurement and position phase. So let's add something different. Let's add a fill height gadget. Okay, so fill width is the same. We're not really interested in width on a vertical layout container because it can either be fill or fixed. And if it's fill, it's the size of the container. But what about the height? Right, the height is their fill height 493. So you can probably guess that fill height containers, gadgets, take up all the remaining space that's left over after we've sorted out the size of all the fixed height gadgets. So in the layout phase, we measure all the child fixed height gadgets, add all those heights together, that leaves us the remaining space, and then we say for every fill height gadget you can take an equal portion of that remaining space. In this example here, we've only got one fill height gadget, so that just takes the entire remaining space, so 526 pixels. And if we scale the container, the layout will be forced again, and that height will change because the remaining space increases or decreases. These don't change because these are a fixed height, so we need a minimum amount of height for these gadgets here. It just changes the amount of remaining space we have here. Okay, that's pretty cool. So let's add another fixed height gadget. If you notice then, as soon as we added that, the height of this one changed. And why is that? Well, it forced the layout because we added another gadget, and it's a fixed height gadget. So the amount of remaining space after our first measurement phase has reduced. We've only got one gadget that wants that space, so that gets all the space that's left, which has been reduced by the height of this one here. So it's gone down to 408. So let's add another gadget. As you can see, these two fill height gadgets are exactly the same height. Well, that makes sense, doesn't it? Because we had remaining space with one gadget that got all the height. We now got 2 gadgets, so that gets half the height per gadget. Now you might think, okay, so how do we sandwich that one in between? Well, as you remember, we have a measurement step and a position step. The measurement step just goes through all the fixed height gadgets first, for that one, that one, that one, skips over that one and goes to that one, just to work out the total height required and the total height remaining, and then it just scales the fill height gadgets accordingly. And then we go to the position phase that basically says, okay, start at the top and just draw the gadgets and add the calculated height when we get to the end, so we can draw the next one. And just to show that again, notice that's 201, 201, let's add the third one, 132. So the height's been split down 3 times, the remaining space has been split 3 times. And that's for a vertical layout container. Now for a horizontal layout container, it's exactly the same process, but we flip the axes basically. So a horizontal layout is only interested in the width of all its child gadgets. The height is either the height of the container or of fixed height. So we just do the same process, but we concentrate on the gadget width. And that's it. So that's gadgets and layouts. That's containers and layouts. It's pretty simple. I haven't written any code or pseudocode. It's better just to demonstrate here. Once you get the concept under the hood, you find it's pretty flexible. You can pretty much make all the UIs you need with just a horizontal or vertical layout container. And that's it. Thank you for watching. I hope to catch you in the next video. Please comment if you want any more advice or any more videos. Bye for now.